It's the zero vector. You cross a vector with itself, you get the zero vector. Now, I actually gave you a vector. You could have actually literally crossed it, and you would have ended up with the zero vector. But no need. Figuring out if the point is on this line, I set the x-coordinate 3 equal to 4 plus t. That would tell me if it's a point on the line, it would have to be there at time -1. Well, you let t equal -1 in the y-coordinate, and you get the y-coordinate matching up. But if you let t equal -1 in the z, no go. Okay? You gotta see how to do this.
Not really.
A point is going to be on this line if at a particular time t I generate out that point. So let me be more specific. If I could observe, for instance, that the point -4, 3, -3 is on the line. The point 6, 5, 1 is on the line. So notice, if you let t equal 0, you get x is 4, y is 3, z is -3. That's a point on the line. If I let t equal 2, I get x is 6, y is 5, and z is 1. That's a point on the line. So to be a point, I've got to find a single value for t that gives me the x, y, and z coordinates. Okay.
So you take one of the components,
Yeah,
plug it in for the variable, and
yeah,
go from there. Okay.
that's exactly. And that's all I'm doing.
Cool.
Okay. It's very rare that I write an Exam1 in a Calc 3 class that doesn't begin with a question like this. It's all bookkeeping. So you cannot add a scalar to a vector. That's total junk.
That's good.
Okay, so that's no good. If you cross W with A, you get back a vector. And then you cross it with V, you get back a vector. Not necessarily the zero vector, but you get back a vector. It'd be the zero vector if you had something, if you had V cross A or something. But this is going to be a vector. You cross W with A, you get a vector. You dot it with V, that gives you a scalar. You dot two vectors. If I took 4, -1, 3 and dotted it with 2, 6, 1, I'd get 8 minus 6 plus 3. It's a scalar. You can, worst comes to worst, you can simply write down a couple vectors and see what you get. but this is going to be a scalar. You dot two vectors, you get a scalar, cross it with the vector v,
Jump.
that's junk.
Is the cross symbol not the same
You
as
can't,
scalar
you
multiplication?
can't,
No, it's not.
Okay.
It's cross. So scalar multiplication, I'm gonna write like this.
Okay.
So these are cross products. And this guy,
close with that,
Scalar.
that's a scalar. It's a magnitude or a length.
Can you put the, number 5 back up? Yeah.
And, you know, you didn't have to cross these two. You could have crossed either one of these with AC or with any multiple of any of these. But regardless of what you cross it with, you will get back a multiple of this. Okay?
so what made you choose your components?
Where? Here?
Because of number 5, yeah, playing through the points,
I
all
have
these points are
points.
different than the components.
So,
Oh, yeah,
yeah, you can't cross points. I mean, you could pretend they're vectors and cross them, but it's pretty meaningless. I have to use those points to generate
Okay.
vectors. So,
So you take
2
a 2
minus
minus
1, 4 minus negative
Minus
4,
Okay.
etc. It's a very common mistake for people to come down here and, you know, treat these as if they are vectors. But that's totally just kind of nothing.
So you found the direction vector first for each one. Is that what that is?
Yeah, A to B.
Yeah, I
Maybe
mean,
it's a
I
direction
just found
vector.
the vector. The vector that begins at
Okay.
one point, ends at the other, you just subtract.
I guess I said
the
direction vector because I think of it as B
Yeah.
minus A.
Yeah, that's
Okay.
fine. Okay. This okay? You want
More?
more?
Yeah, that'd be
Number
great.
7.
Hmm?
Number 7. I was finished writing it down.
Let me see. This would be number 9.
What was wrong with the last part on number 7?
What was
The
wrong
Z
with
Oh, the
this?
petite doesn't
The
match
Z
up, so it's not on the
didn't
far
work.
line. Yeah, so when you plug,
I need a single time that will give me my
it'll generate all
coordinates.
those points.
So if you solve just your x coordinate, to get an x coordinate out of 3, you need the time to be -1. At time -1, the y coordinate is 2, well that's correct. But at time -1, the z didn't match up. So it's not a point on the line. Okay? We said we were covering vector value functions, right? Those first, did we say that?
Section is that?
The first two sections, did we say that?
I think
The R
so.
one.
Yes,
12.
section 13.1 vector value functions, yeah.
And
And
two,
that's before the line
That's
of the
right.
test, so yeah.
making doubly sure.
there a number 14? Is there a number 14? Where's that?
Oh,
No. Okay.
yeah, apparently there it is. You guys all see 9? 9 and then these guys up here. we start looking, magnitude corresponds to length. Be careful which angle you use. If you use the 20-degree angle, then you've got to make your x component negative. Cosine 20 degrees is always positive. If you don't want to worry about pluses and minuses, then use this angle, the standard angle, 160. And then you don't need to worry. But, this is just to tell you, be careful with how pictures are drawn. Because a lot of times in books, they'll just give you this angle, but you still have to compensate.
Would you prefer it in that form, or would you just want the absolute values for the x component?
Well, the x component's got to be negative.
Right. Would you rather have negative 35.7 or negative 38 cosine of 20?
I personally prefer this.
It's the exact.
I prefer it exact partly because I'm lazy and don't feel like punching in. But the other half of me also says, don't round in the middle of a problem, and this is a piece of what you're liable to see in other places. So, best not to round in general. The only advantage I can see to actually punching it in is if you forget to make the minus, maybe you pick it up then.
It's coming from engineering classes, that's what it was.
Okay, here's our prime. To get r, you're going to integrate. So the integral of sine of 3t is minus a third cosine of 3t plus a constant. And then integral of e to the minus 5t is minus 1/5 e to the minus 5t. And it gets its plus a constant. You can go plus c1 plus c2 in the vector stuff, or you can write plus c over here. But this is a vector here. Its components are scalars. To determine what that constant is, r of 0, just plug in your 0, you get this, and it's given that r of 0 is 1, 2. So this will tell me what c is, and then that in turn tells me r. Okay. A cross B is this. You go in reverse order. For cross products, you get negatives. So I just changed the sign of everything here. And notice if A dotted with B is 8, B dotted with A is
-8.
positive 8.
What?
Also 8.
Also 8?
Yes.
Oh, dotted?
Yeah. I mean, you can always check these. If you let A equal 1, 5, and you let B equal 2, -3, say, A dotted with B is 2 minus 15. B dotted with A, 2 minus 15. These are things that if you should forget,
Just
make up a couple vectors and simply compute. You can do the same thing with cross products, although you get 3 dimensions. Okay. Oh, Okay. To project W onto V, to begin with, you've got to put your vectors tail to tail. I'm going onto V, so my vector, whatever it is I go to draw, has got to be a multiple of V. So I'm extending a line all along V. I drop my perpendicular from the head of W down to V. My projection vector is right there.
Is that negative
It
Are we
would
calling
be
that
a negative
of the x-axis?
not of the x's, no x's in
Well, I was
y.
just thinking if there was. Yeah.
Yeah, but I mean, what this would be is going to be a negative multiple of V.
Okay.
Because it's going in the opposite direction.
Okay.
Is it V onto W or W onto V?
I think I said.
Yeah, V onto W.
Okay.
Yeah, it's
Oh,
beyond
yeah.
that.
Oh, I did. Okay, so this is W onto V. If I do V onto W, okay, so I've got V like this, W like this. Because I'm gonna go on to W, I'm gonna look at this line. I'm going to drop a perpendicular from the head of V onto that line. And then my vector projection is this.
We still call that negative because it's negative and it's
It's-
according to the direction of W.
Yeah, it's gonna be a negative multiple of W. So there is a formula which will give this to you, and that formula is gonna have a W dot V up in the numerator, which would be negative in this instance.
Is that the magnitude A, magnitude B cosine?
No,
No.
it's, I'd have to derive it, it's, so if I say what is this guy, it's gonna be W dotted with V over so I'm gonna multiply by W and I want to put a W here. I've just got to derive it. I'm fooling around. So if this angle were theta,
Yeah, W.
I don't know. This is me just being weird. If this is W and this is V, this length right here, that's my theta. That length is magnitude of V cosine theta.
Yeah.
Multiply top and bottom by this.